In this video, I'm going to implement some of the concepts I discussed at the end of the previous video. I suggested playing around with posting events with the Wwise SDK by creating something like a piano roll. I'm going to show you how to do this, as well as some other fun things you can do by simply posting events. I'm also going to introduce spatial audio in this video by establishing an emitter object and a listener object. If you're just joining, in this series of lectures, I'll be walking you through the Wwise SDK and its implementation in my own game engine, as well as in popular game engines like Unity and Unreal. Thanks for watching. First, let's create some objects in the Wwise application. I'm going to create a random container and load some of the footstep sounds that were provided already with the Wwise application. I'm going to pass these footsteps to a random container and tell the engine to vary the pitch with each call. In this way, the timbre of our sound changes, and it will probably be more realistic. You can play with other parameters as well. Next, I'm going to create another random container and load it with some simple synth notes I've created in Ableton. I want these notes to play randomly. Go ahead and generate your sound bank. Remember to place the Wwise ID header file that's generated by our application into your project solution. Otherwise, you may have linker errors. In a future video, I'm going to walk you through creating this game engine, which is a spin-off of 3D Sage's Raycaster engine that is itself inspired by the Wolfenstein Raycaster. In the meantime, know this: we're walking through our world by pressing the keys A, S, D, and W. So whenever any of these keys are pressed, I want to post an event that calls our footsteps random container. I've created a function where by pressing any of the keys, it'll call this event. Whenever a screen is redrawn, the function renderAudio is called. This tells the sound engine to check if any new calls have been made since the previous time the function was called, and to update the playback engine if anything new has been called. Next, I've created a function which calls a random container corresponding to our synth. This is called in the following if statement, which changes the color of our sky. Next, we're going to be covering listeners and emitters in Wwise. A listener is a game object that represents a pair of ears in the game engine. Designating a game option as a listener allows 3D sounds to be assigned to the speakers to mimic a real 3D environment. Similarly, an emitter game object represents a virtual speaker, and when assigned to a listener, the emitter's positional information is mapped into the listener's coordinate system to render a 3D sound. Game objects in Wwise, whether acting as emitters or listeners, or both, are assigned a transform, a position vector, as well as a front and top orientation vector. Game object transforms must be updated on each frame to ensure that sounds are rendered through the correct speakers. Before we get to any of that, we need to include the spatial audio libraries to our project, and we're going to initialize it in our program. Let's go ahead and do that, and create some error checking to check if any errors are produced in the initialization. This function contains the code we programmed in our previous tutorial. By the end of the next lecture, you'll see how this all ties together and why. But for now, imagine this function calls the initialization functions, including the one we just made for spatial audio. First, we need to register our listener as an object in our game that Wwise can recognize. Because our game is first person and has only one character, it's going to be the universal and default listening object. We're going to print into our terminal the initial position of our player. AK vector is a struct, which holds the positions of game objects for the sound engine. First, we're going to pass it the position of our player. My game doesn't have a z-axis, so I'll pass it a value of 1. We pass this struct to the transform function, per the documentation's request. This will prepare the sound engine to receive the initial character position and any modifications later. We'll need to do the same for the player's orientation, per the SDK documentation. The orientation front vector defines the direction that the listener's head is facing. It should be orthogonal to the orientation top vector, which defines the incline of the listener's head. For a human listener, one could think of the orientation front vector as a listener's nose going from the face, while the orientation top vector would be orthogonal to it. going up from the nose, between the listener's eyes, past the forehead, and beyond. The orientation vectors must be defined for the audio to be rendered properly. They cannot be zero vectors, and they need to be unit vectors. They also need to be at right angles. In order to satisfy these demands, we'll pass the following values, and then we pass it to our transform function. Next, we need to tell the sound engine we'd like to set our character position in its respective field of space. We do this by calling the setPosition function in the sound engine class. We'll do a bit of error checking here to make sure everything has worked. Next, we'll do pretty much the exact same thing for our emitter object. Because our listener is going to be walking around in our game engine, we need to update its space in the sound engine. To do this, in our footsteps function, after we post our footstep call, we're going to need to update our position. First, let's print out our position to the terminal and do some error checking to make sure our position is where it should be. Because our emitter will be staying still, our initialized position for it will suffice. Next, in the Wwise application, we're going to create a new SFX object called emitter. You can, like the previous SFX objects we created, modify the parameters of this object. But for now, we just need to modify this object so that it's reacting to the distance of the listener object. In the Positioning tab, check the Listener Relative box and make sure our spatialization is set to position. We also need to make sure our object is marked as emitter. Then, we make a custom attenuation chart. In here, we can modify how the volume changes relative to our player. In my main game function, I'm going to call the emitter post-event function, and then I'm going to compile. We see our sound engine initialization was successful, and our spatial audio module's initialization was also successful. We see our positions were successfully established for our listener and emitter objects in the Wwise engine soundscape. Now that we've loaded the game engine, we can hear the footsteps as we walk around the room. I've added a dot to the map that represents our emitter object. When we move towards our emitter object, its sound gets louder, and as we move away, it gets quieter till it finally disappears. When we press R, the color of the sky changes, and the synth sound is randomly generated. Thanks for watching. I'll see you next time.